So we are looking at point 5 today, solving a linear system. You were asked to solve a system. What that means, that word solve means to find the point of intersection. So for example 1, graph the following system. The system means the two lines that are provided, and then find their solution. So I want you to find the intersection point of these two lines. So let's recall how to graph our lines. My first line, y equals x plus 1. This equation is in slope-intercept form, so I'm going to use my slope and y-intercept to graph. Y equals mx plus b, so m, the number in front of x, that's my slope, so that's 1 over 1, and the constant plus 1, that's my y-intercept. So to graph this line along my y-axis, I move up to 1, because that's my y-intercept, and I put a dot on 1. My slope is 1, and I want to read that as a fraction, so it's 1 over 1. So from the y-intercept, I move up 1, right 1. There are my two dots. I connect arrows on the end to indicate that my line continues on, and I label my work, y equals x plus 1. I'm going to repeat this for my second line, y equals 4x minus 5, starting with my y-intercept, which is negative 5. On my y-axis, move to negative 5, and I mark it there with my red dot. My slope is 4. I want to read that as a fraction, so it's 4 over 1. So starting from my y-intercept of negative 5, I'm going to move up 4, rise 4, and run 1. There's my second dot. So now I'm going to connect those two lines. So remember, we're looking for the point of intersection where my two lines meet. That happens right there. And so the coordinates of the intersection point are 2, 3. So that's the solution to this system. For example B, my system has equations y equals 3x plus 6 and y equals negative 4x minus 8. So again, I'm going to draw these two lines using my slope and my y-intercept. For my first equation, my y-intercept is 6. So on my y-axis, move up to 6 and mark it. My slope is 3. I want to read that as a fraction, so it's 3 over 1. So from 6, I will rise 3, run 1, and connect. For my second line, same thing, starting with my y-intercept, which is negative 8. So down to negative 8, mark it. My slope is negative 4. I want to see that as a fraction, so it's negative 4 over 1. So now when I try to move down 4, I can't see it anymore, right? I'm off the grid. Remember, one action has to be negative. So I can actually take that negative and think of it as being at the bottom, which means my rise is positive 4 and my run is left 1. Okay, so that's the same thing as moving down 4, right 1. I can move up 4, left 1. There's my second point, draw my line. And again, we're looking for the intersection point, so the point of intersection has coordinates negative 2, 0. Example C. So my first equation is presented in slope-intercept form. So I'm going to go ahead and start with my y-intercept is negative 1. There it is. My slope is positive 2. As a fraction, that's 2 over 1. So from this point, I will rise 2, run 1, draw my line. My second equation is not presented in slope-intercept form. It's in standard form. So you have the option of rearranging the equation into slope-intercept form, or solving for the intercepts, or creating a table of values. It's your choice. I'm going to rearrange into slope-intercept form. It's very simple because I have simply a negative y here. So if I move my negative y over to the other side, I have 2x plus 5 equals y. That is slope-intercept form right there. I'm just going to rewrite it so the y is on the left and the slope and intercept are on the right. So starting with my y-intercept, which is 5, mark it. My slope is 2, so it's 2 over 1. So I rise 2, run 1, and connect. So there I have my two lines. So remember, we're looking for the point of intersection. Well, in fact, these lines are parallel. There is no point of intersection, which means no solution exists. So we had our first two examples where we had one intersection point. Our next example here, parallel lines, we have no intersection point. And we're going to look at our third case here. Example D. y equals negative x plus 1. So starting with my y-intercept of positive 1, my slope is negative 1, so it's negative 1 over 1, down 1, right 1, and I connect. And you can see those are the red points there that I've connected and drawn the line. Now my second equation is presented in standard form. So here I'm going to solve for the intercepts. So recall, to solve for my x-intercept, I am going to plug in 0 for y. So I have 4x equals 4, x equals 1. So I'm going to put a blue mark right there on x equals 1. For my y-intercept, repeat the process, but this time x is 0. So I have 4y equals 4, divide both sides by 4, y equals 1. So on my y-axis, go ahead and mark that with the blue dot and connect. And what I see here is that my red line and my blue line are right on top of each other. Well, that's because this equation represents the exact same line. This is presented in slope-intercept form. This is presented in standard form. It's the exact same line, which means when I draw it, the lines will overlap. So the question is asking us to find the intersection point. Well, when I draw one line on top of the other, every single point is the same, which means we have an infinite number of solutions. So we have three cases. We can have one intersection point, we can have no intersection point if my lines are parallel, and finally we can have an infinite number of intersection points if I have the exact same line. Okay, example 2. Determine if the point negative 3, 8 is the solution to the following system. So I'm asking you, is this the intersection point of the two lines? Well, I could draw the lines, but that would be tedious. I can actually solve algebraically. What I'm going to do is test to make sure that negative 3, 8 is a solution to the first line. Then I'm going to test to see if negative 3, 8 is a solution to my second line. If it's a solution to both lines, then that means that both lines pass through that point, which means it must be the intersection point. So starting with my first equation, 2x minus 3y equals negative 30. I'm going to take my left-hand side, I'm going to take my right-hand side separately, I'm going to sub in negative 3, 8 for x and y and make sure that they match. And they do. I plug in and I end up with negative 30 on the left, negative 30 on the right. Since they equal each other, that means on the line. Now I'm going to repeat this process for my second line. Left-hand side reads x minus 0.5y plus 7, and my right-hand side is 0. So I'm going to plug in negative 3 for x, 8 for y, and I simplify my left-hand side, and I get 0 on the left, 0 on the right. Again, left side equals right side, they match, which means that this point is on both lines, which means that it must be the solution to the system. So let's look at another example where we see it doesn't work, just so that you can see the difference. So determine if the point 2, negative 1 is a solution to this system. So again, I repeat. For my first equation, 2x minus 7y equals positive 11, take my left-hand side, take my right-hand side, sub in 2 for x, negative 1 for y. I end up with 11 on the left, 11 on the right. So left side equals right side, which means that yes, 2, negative 1 is a point on this line. Now I'm going to repeat for my second line. Y equals negative 0.5x minus 3. So on the left-hand side, I have y, which is negative 1. On the right-hand side, negative 0.5 times x, which is 2 minus 3. I simplify, and here I get negative 4. So my left-hand side does not match my right-hand. It tells me that this point 2, negative 1 is not a point on this line. This line doesn't pass through that point. So the original question is 2, negative 1 the solution to the system? Do the two lines intersect at that point? And let's look at our last example for today. Example 4. Movies to Go rents DVDs for $2.50 and has no membership fee. Films R Us rents videos for $2 but has a $10 membership fee. What advice would you give to someone who's deciding which video store to use? So first of all, I need to come up with equations, one for Movies to Go and the second one for Films R Us. So before I can write out my equations, I'm going to assign variables. So I'm going to let Y be the total cost, and I'm going to let X be the number of DVDs rented. So at Movies to Go, $2.50 per DVD, no membership fee, gives me an equation of Y equals 2.5 times X. Films R Us, they're charging $2, but they have a $10 membership fee, so my equation here becomes Y equals 2X plus 10. So what I want to do is I want to find the solution to this system. I want to find the point where these two lines, will intersect. And then at that point I can determine when one store will be more expensive or less expensive than the other. So I am going to create a grid. On my grid, I have to choose an appropriate scale to move up by. So my x-axis represents the number of videos that I've rented in a month. So I'm going to go up by 2s, from 2 to 20. That's reasonable. For my cost, I'm going to move from $10 to $100, increments of 10. So y equals 2.5x. I can create a table of values. I can use the intercepts. I can use my slope and my y-intercept. Okay, so I've created a table to help us see things a little bit easier. So when x is 0, when I rent 0 DVDs, my charge is $0. When I rent 10 DVDs, my charge is $25, so 10, 25, and I connect with my green line. For Films R Us, when I rent 0 DVDs, there's a $10 charge. That's my membership fee. And when I rent 10 DVDs, plug in 10, 2 times 10 plus 10 gives me $30, so 10, 30. So you can see that for renting 10 DVDs, it's cheaper to use Movies to Go, right? More expensive for Films R Us. And I connect, and there we go. So what happens is I have this point of intersection. Now my intersection point happens at 2050. So that means that when I rent 20 DVDs at Movies to Go, I need to pay $50. When I rent 20 movies at Films R Us, again I have to pay $50. So it's the same cost to rent 20 DVDs. Well, what we're interested in is what happens when I rent more or less than 20 DVDs. Well, when I rent less than 20 DVDs, you can see that my green line, Film Movies to Go, will be less expensive. When I rent more than 20 DVDs, you can see that my red line, Films R Us, will be less expensive to use. So that's what I want to write up in my final statement. My intersection point is 2050. So again, when I rent 20 DVDs, the cost is the same. It's $50. When I rent less than 20 DVDs, it will be less expensive to use Movies to Go. And when I rent more than 20 DVDs, it will be less expensive to use Films R Us. So that would be my advice to a customer. If we're renting less than 20, choose Movies to Go. If we're renting more than 20, choose Films R Us. Finally, for homework, I'd like you to look at page 245, numbers 1ABD, 2, 6, 8AC, and 12B. If you have any problems, please contact me through email or Google Classroom, and I'll get back to you as soon as possible. Thank you guys. Have a good day.